Hi everyone, good morning and welcome to our webinar. Today we are going to talk about string handling in Enhanced IEC, and the presentation should last around 20 minutes. As always, if you have any questions, please add them in the question panel and we will go through them at the end of the presentation. That said, let's get started.
Hello and welcome to today's webinar. Today we will be looking at string handling in Enhanced IEC. Let's look at our agenda for today. We will begin by comparing Standard IEC and Enhanced IEC. We will then discuss what additional functions and capabilities Enhanced IEC offers versus Standard IEC. We will also look at the requirements that need to be met in order to use Enhanced IEC. Then we will define string handling and look at where it is used. Finally, we will look at the exclusive capabilities of Enhanced IEC for dealing with strings. There will be demonstrations throughout, and we will finish with a Q&A session. First, we will compare Standard IEC and Enhanced IEC. Standard IEC has been available for many years, is compatible with all Horner controllers, and is available in the standard Cscape version. There are also some minor limitations with Standard IEC. For one, you are limited to 10,000 variables when you are using Standard IEC. Standard IEC also has a slightly slower scan rate than Advanced Ladder. From a user-based standpoint, Advanced Ladder is still the most popular logic language available in Cscape. However, IEC languages are growing quickly. This is because IEC languages offer the capability of using multiple languages such as structured text. Now we will look at the features of Enhanced IEC and the requirements to use it. Similar to Standard IEC, Enhanced IEC is available in Standard Cscape. This has been available since Cscape 9.9 Service Pack 4. Enhanced IEC is compatible with most RCC models, the XL Prime series, as well as the XL5 and the XL4 through to the EXL10. The Micro OCS, XLE, and XLT series use Standard IEC only. There is also a one-time upgrade fee for your OCS to support Enhanced IEC. Enhanced IEC supports 64,000 variables, compared to the 10,000 that Standard IEC supports. Enhanced IEC also has the same performance and execution rate as Advanced Ladder. Additional features of Enhanced IEC include online programming, which Standard IEC does not support. This allows you to make logic changes in your controller without stopping the controller. There is also a simulation mode available in Enhanced IEC. As well as this, Enhanced IEC provides additional instructions and data types. We will be looking at the additional string instructions that are embedded in the native command set for Enhanced IEC today that are not available in Standard IEC or in Advanced Ladder. Next, we will take a quick look at string handling. String handling is the manipulation of string-type variables. String-type variables are based on ASCII encoding, where each character in a string is represented by a byte value or a short integer value, which ranges from 0 to 127. So each value matches up with a specific character as seen in the ASCII table shown. The standard IEC editor handles strings as unsigned short integer arrays. The Enhanced IEC editor can also handle strings as arrays, as well as handle strings using the string data type. There are many applications of string handling where it is a crucial aspect of the control. These include barcodes, reading and writing RFID tags, magnetic card readers printing to serial, USB-based printers for receipts, and satellite communication. Now we will look at the string functionality available in Enhanced IEC. If we navigate from the project toolbox in Cscape to the string category, we can see the different instructions available to use for string handling. This can be seen in the screenshot shown. We have categorized these functions by what they are useful for. For example, some functions are useful for converting strings back and forth between the string format and the array format. This is helpful in cases where we may want to deal with the string as an array, as it is easier to step through character by character and examine characters individually. String parsing is another critical part of string handling, which is extracting a portion of an overall string to get a piece of data and to deal with a piece of data that you are interested in. Enhanced IEC also has string editing functions that are not always available with other languages, such as the ability to delete, insert, and replace individual characters. Similar to other languages, Enhanced IEC offers string building functions for concatenating strings together, which can be used to build up a string that will be sent out to an automation device such as a printer. There are also functions for finding the length of a string and for finding a series of characters within a larger string. These are just some of the many different functionalities included in the Enhanced IEC instruction set. All of these functions are available in structured text, function block diagram, and ladder. However, in today's demonstrations, we will focus on structured text syntax. The functions that are exclusive to Enhanced IEC are highlighted here. These are string conversion, string parsing, string editing, string building, string length, and string find functions. We will look at each of these in our demonstrations today. We will first look at string conversion functions. These allow us to convert variables from the string format to the array format, or the array format to the string format if needed. Once again, we will note that unlike standard IEC, which handles integers as unsigned short integer arrays, Enhanced IEC handles strings as short integer arrays. Let's look at these functions in Cscape. In the following demonstrations, we will first look at the syntax for these functions, then look at how they are used, and finally look at the simulation capability that's available in Enhanced IEC. Let's look at our first string conversion functions. We will first look at the array to string function. For this string, we have three inputs. The first input is a source array, which we will use as the source of our conversion, and is assigned integer array of characters. Our second input is the name of the string variable we will be creating or writing those characters to. Our third input is a double integer value, which specifies how many characters we want to copy from the source array, starting at the beginning, over to the string variable. Here we have this as a constant of 10. The output of the function will then be the number of characters that were moved. If we want to use the function to convert a string to an array format, the first input will be the source string, which is the source of where the characters are coming from. The second input will be the name of the short integer array, which is where we will copy the characters to. The output of this function will represent how many characters were moved. Now we will turn on the simulation view and select our string conversion subroutine. First, we will look at the array to string function. Our source string is being written to from our source short integer array. The result of this is ABCDEFGHIJ, which is the first 10 characters of our source array that have been copied into our string. If we started out with this string and we wanted to convert this to an array, we would specify a different destination array, which is an array of short integers, and we will get an output that shows us 10 characters removed. The difference between these two functions is when we are going from an array to a string, we specify how many characters to move. When we go from a string to an array, it tells you how many characters were moved, because we always move the entire string. The next two conversion functions we will look at can be used to convert values from ASCII to hex format and hex to ASCII format. Let's say we were communicating with an automation device over TCP or a serial port that is sending us data as a string, which represents a hexadecimal data value. We could use one of these functions to convert this value to a number value if needed. We could then use the ASCII to hex function to convert a number to a hexadecimal value if we were sending data back to that same device. Now we will return to Cscape and look at these functions. Our ASCII to hex function has strictly one input, which is the string we will interpret as a hex value. Then we will take this hex value we are reading in and convert it to a double integer. For example, the data coming in is A0 as a string, which represents a hexadecimal value of A0. We want to take this string value and convert it to a number. Here our A0 string is the input. The output of this function is then this value in decimal. To convert this value back to a hexadecimal value, we want to send it out as a hex string, and the output is the string that we created. Now we will turn on simulation mode again and select our string conversion subroutine. Here we can see that the string we have as our input for our ASCII to hex conversion is coming in as A0, which is 160 in decimal, and so our output is a double integer of 160. If we then convert this back to hexadecimal, if 160 is our input as a double integer, then our output will be the string of A0. Next, we will look at the string parsing functions that are native to enhanced IEC. These functions can be used to extract a series of characters from either the left side or beginning of a string, the right side or end of a string, or somewhere in the middle of a string. These functions are used to extract a portion of a source string and then store it in a destination string. Now let's demonstrate these string functions in Cscape. Here our code shows a source string that we have fixed at a constant, and then we are demonstrating the string left, string right, and string mid functions. For the string left inputs, we specify our source string, as well as how many characters we want to extract from the string. We also have the name of the string we will copy these into. We have these same inputs for the string right function, except we are instead specifying how many characters we will extract from the right or end of the string and copy into another string. For the string mid function, we have to specify how many characters we want to extract, as well as the starting position that we want to extract it from. We have noted here that this position is 0 based, so if we specify 5 here, this would be the 6th position within the string. Let's return to our simulation mode and select our string parsing subroutine. Here we can see the results from our functions using an example source string. If we extract 3 characters from the left, we get 1, 2, 3. If we extract 3 characters from the right, we get 4, 5, 6. And if we extract 3 characters from index number 5, which is the 6th position in the array, we get C, 4, 5. As C is in the 6th position in the source string, so we extract this, as well as the 2 characters after this. Next, we will look at the string editing functions. Once again, these are native functions in enhanced IEC. These can be used to insert characters into a string, delete characters from a string, replace certain characters in a string with different characters, or join multiple strings together. Now let's return to Cscape and look at the syntax for these string editing functions. First, let's look at the delete characters function. Our first input will be the string that we want to work on. Our second input is the starting position that we want to start deleting from. This starting position is 0 based, so position 0 is the first position. Our third input is how many characters we want to delete. So in this example, we will delete the first 3 characters. Next, we have the insert characters function. For this function, our first input is the string we will be working on. The second input is the string or series of characters we will insert in string data format. The third input is the position we want to insert these strings into. This is also a 0 based position. Next, we will look at the string replace function. The first input is the string we are working on. The second input is the string we will insert into the original string. For the third and fourth inputs, we need to specify how many characters we will replace and at what starting position we will replace them in. Now we will look at these functions in simulation mode and select our string editing subroutine. Here we can see our example starting string, as well as the results we get if we delete the first 3 characters from the string, then insert the string 123 into the 3rd position of this new string, and finally replace the first 3 characters in the string to edit with the characters 123 starting from the 1st position. We will also look at an example using the concatenate function. We can use this function to join together multiple strings. There are different ways that we can do this. If we want to use the concatenate function, we will put the strings we want to join in list form separated by commas. Alternatively, we can use the plus function, with the strings we want to join together separated by the plus sign. Both of these methods can be used to join multiple strings together. Now we will look at string length functions. These are used to calculate the length of a string. We can also use a function to compare strings. The string data type doesn't need a special function to compare 2 strings. Instead, we can use equality test coding to test if 2 strings are matching or not. We can also test to see if a string matches with a fixed set of characters, which is what we are showing an example of here. Now let's look at these functions in Cscape. First, we will look at the string length function. For this function, we need to specify the string and string type we want to check the length of. The output will then be the length as an integer value. To compare strings, we can use standard structured text syntax to see if a particular pair of strings match. Next, we will look at the string find function. We can use this function to find the position of a series of characters called a search string in an original string. We will also look at the character ASCII code, which we can use to specify the position of a search string within a string. Now we will return to Cscape. Here we have our string find function, which has the name of the string we will be searching as our first input. The second input is the series of characters in string form that we're looking for. This built-in function allows us to find a whole series of characters within another set with an original string. The output of this function is the position where that string is located. We have noted here that this position is 1-based. Now let's look at our character ASCII function. For our first input, we specify the string where the character that we want the ASCII code for is located. The second input is the position within this string, which is 0-based, where we will find the character we want to test or want to retrieve the ASCII code of. In this example, the first character is character number 0. We then get this output as a double integer value. Finally, we will take a quick look at a CRC calculation function, which is a built-in function in Enhanced IEC. We can use this to calculate the Modbus CRC from a source string. This could be used if you were building your own string and talking to a device that uses a non-standard version of Modbus, and you need to calculate a CRC. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, I'm back. Let me just check if we had any questions. Not so far. In this case, let me jump into my screen. I hope you all can see that. The next webinar is going to be about string handling and structured text. And the week after is going to be about find operations using structured text. And if you are interested, please register on our website. I believe that's all for today. Thank you. Thank you, everyone. for your time, and I hope to see you in the next webinar. Have a nice day.